In this video, we're looking at factorizing special binomial products. So the first special binomial product we're going to be factorizing is something called factorizing by grouping in pairs. So when you have an algebraic expression with 4 terms, we can sometimes factorize these into pairs, which means 2 terms at a time, to make a binomial product. So these steps involve first grouping into pairs before we even start to factorize. Once we do this, we factorize each of those pairs, and then usually you end up with 2 parts of the pairs that are the same, which allows you to factorize further to get a binomial product. So that might sound confusing, so I would show you with an example. So here we have the first one. I'm going to rewrite it. Alright, so when we say break it up into 2 pairs, what we're saying is we have 1 pair here and we have 1 pair here. Sometimes you may need to do some rearranging to get the best pair, but in this case we're just going to look at the first 2. So if we're focusing on our red box, we need to factorize this down. Now remember, you need to find the highest common factor. So first thing you do is, what's the highest common factor for 9 and 6? That's 3. So it comes out the front. You then look for any common letters or pronumerals. In this case, C is common, it's in both, so I can write that down. There's nothing else common, so I put my first bracket, and then I go, well, what's 9AC divided by 3C? So I'll do it over here, 9AC divided by 3C, and that gets me 3A. So I know 3A goes there. I then get 6BC and divided by 3C, and I get 2B. I then look at our blue, and I go, well, what's common here? The biggest number that's common here is my 4. And then I look for any letters that are common. In this case, D is common, so I pull D out. Nothing else is common, put my first bracket. Now 12AD divided by 4D is 3A. 8BD divided by 4D is 2B. Now you'll notice, I'll do this in a black pen, you'll notice that these are the same. If these are the same, it's a good indication you've done the right thing, because the next step is to further factorize these down, because those black boxes there are our common factor for these 2 terms. So what we do is we write that out the front, 3A plus 2B. I then write whatever's left over. So if I removed the first black box, so if I remove this, we have 3C left over. If I remove this, we have 4D left over. And there you go. That's your factorized expression. All right, so I'm going to do it again. So we have L3 plus LM squared minus 3L squared minus 3M squared. So again, break it up into our pairs. So we have L that's common between here, so L comes out the front. Nothing else is common, so I'm left with L squared plus M squared here. I then go to the blue, and I go, well, negative 3 is my common term there. And then I'm left over with L squared, M squared. And again, you'll notice that this bracketed and this bracketed expression are the same, so we can write those out the front, and then we write what's left over. So that's disappeared, I'm left with L, that's disappeared, I'm left with minus 3, and that's our factorized expression. So that is what we call factorizing by grouping in pairs. You do find your 2 pairs. It's a good idea to maybe draw up your boxes like I have there with different colors, so you can really clearly see what you're factorizing, but you don't have to. The next thing we're looking at is factorizing the difference of 2 squares. So remember, when we had A plus B, A minus B, when we expand that, we get A squared minus B squared. We can reverse this rule to show the factors of A squared minus B squared, so it's just the reverse. So what we do here is, if I write this down, for me to know that it's a difference of 2 squares, both terms need to be a square number. So x squared is a square number, and 4 is also a square number. So if I'm trying to find what my a is, my a is going to be the square root of my first term, so x squared. And my b is going to be the square root of my next term. So this comes out as 2, and this comes out as x. So what that means is if I'm trying to factorize this down, I get left with my a. So all we're doing is filling in our a's and b's up here. So a we said was x, b was 2, then we write it again, x minus 2. Alright, so you square root both your terms that you have. So we square rooted x squared to get x, which is our a, and we square rooted 4 to get our b value, which was 2, and then we just substitute them in. So if we look at this one, we have 36c squared minus 25k squared. So my a is going to be the square root of 36c squared, and b will be the square root of 25k squared. So the square root of that is, so we can break this up and do it in parts. So the square root of 36 is 6, the square root of c squared is c, then I go down here, the square root of 25 is 5, the square root of k squared is k. So that's my a's and b's. Remember, our formula states that a plus b, a minus b, so I can just substitute these in. So we have 6c plus 5k, 6c minus 5k. So to recap the video so far, remember when you're factorizing by grouping in pairs, you first group them into your pairs you want. I use the boxes to really clearly identify what my pairs are. You then factorize these pairs. If you've done it correctly, you'll notice that the two bracketed parts are the same, which are then you can factorize further to get your final binomial product. So again, when we're factorizing the difference of two squares, it's just the reverse of what we do. You still use the same formula, but start by square rooting both terms to get your a and your b, and then you can just substitute it in.